One relationship that we have to deal with is one that you're already very familiar with from driving. We have to deal with the relationship between speed and distance traveled and time required. But again, we're going to handle speed the same way that your car does. The speedometer in your dash, your speedometer, measures speed as miles per hour, a distance traveled divided by how long it took to get there. So for example, if you're going to go to Grandma's house and you know that it's 300 miles to Grandma's house, since you've driven this before, you know also that you can average about 60 miles per hour. So how long is it going to take to get there? Well, we can work that. If we know that our average speed for this journey is going to be 60 miles per hour, and that the distance we have to travel is about 300 miles, we can calculate how long the journey is going to last, the time it's going to take us to get there. Got a little bit of math to do, of course. A lot of ways to go here, but one way, I can multiply both sides of the equation by time. Remember, I've got to be completely fair and do exactly to one side what I do to the other. So if I multiply the right side of the equation by time, I also have to multiply the left side of the equation by time. That means time is going to cancel out on the right. I'm going to get it out of the downstairs. But I'm not done yet. I've got time multiplied by 60 miles per hour equals 300 miles. Now I need to divide both sides by 60. Again, got to be fair. If I divide the left side by 60 miles per hour, also got to divide the right side by 60 miles per hour. That's going to cancel the 60s. That's going to get them off out of the left-hand side. On the left, all by itself, I have the time this journey is going to take. On the right, got a little bit of calculator work to do. 300 divided by 60. Okay, that's fine. But I also have to deal with these units. Now remember, a fraction on the bottom has to be flipped over and moved upstairs. So that's the same thing as miles multiplied by hours over miles. Oh, okay. That looks better because the miles up top and on bottom cancel, and I'm just left with plain old hours. 5 hours is how long this journey lasts. Now, let's look at another one. Let's suppose that we were driving at 60 miles an hour, but suppose we were going to be able to drive to the moon, and we wanted to calculate how long it would take for that journey. Now, the moon's, well, quite a bit farther away. In fact, the average distance between the Earth and the Moon is somewhere around 240,000 miles. So I would work this in much the same way, but this time, my distance traveled is not just 300 miles, it's 240,000 miles. But again, I would multiply both sides by time. That gets time out of the downstairs. Then I'm going to have to divide both sides by 60. That's going to get rid of the 60 on the left. And so finally, how long would it take me to drive to the moon if I could drive to the moon? Well, I've got 240,000 divided by 60. That's going to be 4,000. But 4,000 what? Again, I've got to deal with those units. Just like before, we've got miles divided by miles per hour. Anytime I have a fraction on the bottom, I've got to flip it, move it up top. Again, the miles times hours over miles are going to mean I'm left with plain old hours. 4,000 hours. That's over 166 days. That's over 5 months. It would take over 5 months to drive to the moon if I could. Now, light is a lot faster than your car. In fact, light travels at a speed of 186,000 miles every single second. Not miles per hour, miles per second. So, Calculate, please, how long it takes light to go to the moon. See what you get.